Okay, so in this video, we want to give a quick word of caution about a property that is not true of exponents, and that is you cannot distribute an exponent over a sum of two terms. So in general, if you have x plus y to the nth power, this will not be equal to x to the n plus y to the n. Of course, the equality is true if n is 1, so we state here if n is anything but 1. And this is really easily verified. Let's look at two examples. Let's leave x and y first as variables, and then pick simply n to be 2. So if we call this, say, the left-hand side, and this the right-hand side, let's look at both sides when, again, x and y are variables, and n is 2. So we have therefore the left-hand side will be x plus y squared, which is by definition, if we expand x plus y times x plus y, and if we multiply out, then we have cross terms, right? X times x plus x times y plus y times x, and finally plus y times y. We can simplify a bit. X times x is x squared. X, y, and y, x are the same. So what we have here, if we combine, is 2 times xy plus y squared. So this is the result of our left-hand side when n equals 2. We get x squared plus 2xy plus y squared. Now what is the right-hand side in this case? Well, if n is 2, the right-hand side is x squared plus y squared. We're missing the middle term, which came from expanding out x plus y times x plus y. We're missing the cross term. So clearly this is not equal to the left-hand side. So very simple counterexample that you cannot distribute an exponent onto a sum of terms. Let's give now an even simpler example where we still take n to be 2 and x and y to be positive integers. So what if we say that we take x to be 2, y to be 3, and n to be 2. So we have 2 plus 3 squared. This is our left-hand side. Well, of course we could do the same thing we did here for x and y, but as we can add 2 and 3, we can do much simpler. This is simply 5 squared, which of course is 25. Now what about the right-hand side? Again, x is 2, y is 3, and n in each case is 2, so we have 2 squared plus 3 squared, which is simply 4 plus 9, which is 13, which clearly is not 25. So again, if you ever are about to distribute an exponent onto a sum of two terms, you can think of it in two ways. When you multiply an expression that involves a sum, you will then obtain a lot of cross terms, which will be omitted if you simply exponentiate both individual terms. So again, you cannot distribute an exponent onto a sum of terms. And hopefully this shows you why this is, thinking of this equals this, is extremely, extremely wrong. And that's it.